Many candidates spend weeks memorizing LEED credits, only to lose valuable exam points because they do not fully understand how the entire certification process works from start to finish. That single mistake can turn straightforward questions into confusing ones and lower your score on exam day. In this complete study guide, you will build a clear understanding of the full LEED framework, avoid common exam traps, and gain practical knowledge that also applies to real-world green building projects. Be sure to download the free LEED app study guide with the most important practice questions using the link in the description to reinforce everything you learn in this video. Welcome to this complete LEED app, accredited professional, exam prep study guide. We will begin with one of the most important topics on the entire exam, the LEED certification process and the integrative design approach. These concepts provide the foundation for every LEED project and influence decisions from the earliest planning stages through final certification. As you progress through all 6 sections of this course, you will develop a complete understanding of the LEED rating system, project requirements, sustainable design strategies, and the key concepts most frequently tested on the exam. By the end of this video, you will have a strong conceptual framework that makes the rest of the exam content easier to understand and remember. Let's get started. LEED stands for Leadership in Energy and Environmental Design, and it is the most widely used green building rating system in the world. It provides a framework for healthy, highly efficient, and cost-saving green buildings. When you pass your exam, you become an accredited professional who helps developers and architects navigate this framework. The exam will test your understanding of how LEED transforms traditional building practices into environmentally responsible ones. Think of LEED as a comprehensive scorecard that rewards projects for making sustainable choices. The LEED framework is not just one single checklist, but rather a collection of different rating systems tailored to specific project types. For example, there is a distinct rating system for new construction, another for existing buildings, and even one specifically for entire neighborhoods. Before starting any project, the team must select the most appropriate rating system based on the scope of their work. A common exam question will ask you to identify the correct rating system for a given scenario, such as a commercial interior renovation versus a newly built hospital. The 40-60 rule is a handy tool used to decide which rating system applies when a project seems to fit into more than one category. The 40-60 rule is a simple mathematical guideline you must memorize for the exam. If a particular rating system is appropriate for less than 40% of the gross floor area of a project, you should not use that system. If it is appropriate for more than 60% of the gross floor area, you should definitely use that rating system. If the appropriate area falls exactly between 40 and 60%, the project team can independently decide which rating system best serves their goals. This rule prevents confusion and ensures that the certification standards match the actual physical reality of the building. Before a building can even try to earn LEED points, it must meet 3 minimum program requirements, often called MPRs. These are the absolute basic characteristics that a project must possess to be eligible for certification. First, the project must be in a permanent location on existing land, meaning you cannot certify a mobile home or a boat. Second, it must use reasonable LEED boundaries, which means the project cannot gerrymander its property lines to exclude difficult areas from the certification. Third, the project must comply with strict project size requirements to ensure the evaluation is meaningful. Once the minimum program requirements are met, the project team will encounter 2 distinct types of criteria within the LEED scorecard, which are prerequisites and credits. Prerequisites are mandatory requirements that every single project must achieve, and they do not award any points. If a project fails to meet even one prerequisite, it is completely disqualified from LEED certification, no matter how many other points it has earned. Credits, on the other hand, are strictly optional, and they are the mechanism by which a project actually earns points. The exam will heavily test your ability to distinguish between mandatory prerequisites and optional point-earning credits. As a project successfully achieves optional credits, it accumulates points that determine its final certification level. There are exactly 100 base points available, plus 10 bonus points, for a total of 110 possible points. A project needs a minimum of 40 points to become merely LEED certified. Earning 50 to 59 points achieves silver status, while 60 to 79 points earns gold. If a project earns 80 or more points, it reaches the highest possible level, which is platinum. To achieve these high certification levels, Teams must move away from the traditional design process and embrace the integrative process. In traditional construction, the architect designs the building, then hands the plans to the engineers, who then hand them to the builders, working in isolated silos. This linear approach often leads to missed opportunities, expensive late-stage changes, and inefficient buildings. The LEED system strongly penalizes this old-fashioned way of thinking because it treats building systems as separate pieces rather than parts of a whole. The exam expects you to understand why traditional design fails in sustainability. The integrative process is a collaborative, highly interactive approach that brings all project team members together from the very beginning. Architects, engineers, contractors, landscape designers, and even the building owners sit down at the same table during the earliest planning stages. By collaborating early, the team can discover hidden synergies where one sustainable design choice benefits multiple different building systems at once. For example, positioning windows to maximize natural daylight might reduce the need for electrical lighting, which in turn reduces the size needed for the air conditioning system. This holistic view is the beating heart of the LEED philosophy. The integrative process is officially broken down into 3 distinct phases that you need to know for the exam. The first phase is discovery, which happens before any actual design work begins, focusing on deep research and goal setting. The second phase is design and construction, where the team actively implements the strategies identified during the discovery phase. The third and final phase is occupancy, operations, and performance feedback, which ensures the building actually performs as intended once people move inside. The discovery phase is heavily emphasized in LEED because early decisions have the biggest impact and cost the least to implement. A major concept within the integrative process is systems thinking, which is the understanding that everything is connected. Instead of viewing a building as a simple shelter, systems thinking views it as a complex living organism where every component interacts with the others. If you change the type of glass on the windows, you immediately alter the heating loads, cooling loads, and interior lighting conditions of the building. Exam questions often present a scenario where one change is made, and ask you to identify the cascading effects on other building systems. Mastering systems thinking allows you to anticipate these ripples and design more efficient structures. Within systems thinking, you must understand the difference between open systems and closed systems. An open system constantly takes in new resources from the outside, uses them once, and expels them as waste, much like a traditional building pulling in fresh water and sending it straight to the sewer. A closed system, however, loops its resources in a continuous cycle, where the waste of one process becomes the food for another. LEED strongly encourages pushing building designs toward closed systems, such as capturing rainwater to flush toilets or using organic waste for on-site composting. The certification exam will reward your ability to identify closed-loop solutions. Another vital tool used during the integrative process is the life cycle assessment, commonly abbreviated as LCA. This is an analytical method used to evaluate the total environmental impact of a building material over its entire existence. It looks at the extraction of raw materials, manufacturing, transportation, installation, daily use, and final disposal at the end of the life of the building. Instead of just asking how much a material costs to buy, an LCA asks what the material costs the planet from cradle to grave. Understanding life cycle assessment helps teams choose materials that are truly sustainable, rather than just superficially green. While life cycle assessment looks at environmental impacts, life cycle costing, or LCC, looks at the financial side of the equation. LCC evaluates the total monetary cost of a building or system over its entire useful life, rather than just looking at the initial purchase price. A highly efficient air conditioning system might cost more money up front, but a life cycle costing analysis will prove that the energy savings over 20 years will far outweigh that initial premium. LEED teams use this financial tool to convince building owners that sustainable choices are actually smart long-term investments. The exam will frequently test your ability to differentiate between environmental LCA and financial LCC. When a project officially registers for LEED certification, one person must be designated as the project administrator. This individual acts as the primary point of contact with the Green Business Certification Incorporated, which is the organization that actually reviews and approves LEED applications. The project administrator is responsible for assigning specific credits to different team members and ensuring that all documentation is accurate before submission. While this person does not need to be a LEED accredited professional, having a LEED app on the team does earn the project one bonus point. Managing the workflow through the online portal is a key part of this leadership role. The entire certification process is managed digitally through a central platform called LEED Online. This is the official workspace where the project team uploads floor plans, submits energy models, and fills out the necessary credit templates. It acts as a collaborative hub, allowing a mechanical engineer in one city and an architect in another to work on the exact same project simultaneously. When you take the exam, you will be expected to know that LEED Online is the mandatory portal for documenting credits, communicating with reviewers, and submitting the final application. It completely eliminates the need for paper submissions and streamlines the entire review workflow. Sometimes, a project team encounters a unique situation that is not clearly addressed by the standard LEED reference guide. When this happens, the team can submit a credit interpretation ruling, or CIR, through LEED Online to ask for official clarification. A CIR is a formal question asking the reviewers if a specific, alternative strategy meets the intent of a particular credit. It is important to know that a CIR is not a guarantee of points, but rather a technical guidance mechanism to help the team proceed with confidence. Submitting a CIR costs money, so teams are strongly encouraged to search the database of previous rulings before asking a new question. The actual review of the LEED application typically happens in two distinct stages, which are the standard preliminary review and the final review. During the preliminary review, the reviewers evaluate the submitted documents and return a report indicating which credits are anticipated to be awarded, and which ones need more information. The project team then has an opportunity to provide additional data, fix mistakes, and clarify their strategies during the final review phase. Projects can also choose to split their review into a design phase and a construction phase to get early feedback before the building is actually built. This phased approach dramatically reduces the risk of expensive surprises at the end of the project. Everything we have discussed in this section ties back to the core philosophy of LEED, which is the triple bottom line. This concept states that true sustainability must balance three crucial elements, which are people, planet, and profit. A building is only truly successful if it improves the health and well-being of the people inside, protects the natural environment, and makes economic sense for the owner. If a project focuses entirely on environmental protection but bankrupts the developer, it has failed the triple bottom line test. The exam requires you to view every design decision through this three-part lens of social, environmental, and economic responsibility. Congratulations on successfully completing the first section of your LEED app preparation course. I highly encourage you to immediately complete the attached practice test for this specific module. Engaging with practice questions right now will dramatically improve your knowledge retention and ensure you are truly ready for the style of the real exam. Remember that this practice test is included right here with your lesson, and using it is the absolute best form of active learning. Once you have solidified your understanding of the LEED process, I look forward to seeing you in the next section where we will tackle location and transportation strategies. Welcome to the second section of our course, focusing on where we build and how it impacts the surrounding environment. In this lesson, you will discover the critical strategies behind selecting optimal building locations, promoting alternative transportation, and protecting delicate natural ecosystems. Understanding site selection is vital because a highly efficient green building placed in the wrong location can still cause massive environmental damage. Get ready to shift your perspective from the building itself to the community and landscape that surround it. Let us explore how smart site design sets the stage for a truly sustainable project. The first major category we will discuss is location and transportation, which rewards projects for choosing sites in already developed areas. Instead of building on untouched land, LEED encourages developers to select infill sites, which are empty lots surrounded by existing buildings and infrastructure. Building on an infill site means you do not have to clear new forests or extend city water pipes and power lines for miles out into the wilderness. This strategy preserves natural habitats while simultaneously revitalizing older, neglected neighborhoods. The exam will frequently test your ability to recognize the environmental and economic benefits of choosing an infill development site. Conversely, LEED heavily penalizes building on sensitive lands that provide vital ecosystem services. You must avoid constructing on prime farmland, floodplains, habitats for endangered species, and areas close to wetlands or natural water bodies. Protecting these areas ensures that natural flood control, local food production, and biodiversity are maintained for future generations. If a project team absolutely must build near a wetland, they are required to maintain strict buffer zones to prevent construction runoff from polluting the delicate water systems. Expect exam questions to ask about the specific types of land that are restricted from green building development. To push sustainable development even further, LEED awards points for building on high-priority sites, particularly brownfields. A brownfield is a piece of property where expansion or redevelopment is complicated by the presence of hazardous substances, pollutants, or contaminants. An old gas station with leaking underground tanks or an abandoned factory are classic examples of brownfield sites. By choosing to clean up and build on a brownfield, a developer removes toxic waste from the community and turns a dangerous eyesore into a valuable community asset. Healing damaged land is a heavily rewarded concept on the certification exam. Another key location strategy involves placing your building in an area with high density and diverse uses. This means selecting a site that is within a short walking distance of basic services like grocery stores, banks, restaurants, and pharmacies. When people can easily walk to their daily errands, they do not need to drive their cars, which drastically reduces greenhouse gas emissions and traffic congestion. The exam often refers to this as creating a walkable neighborhood, and it is a fundamental goal of sustainable urban planning. A well-chosen site connects the building to the surrounding community and promotes a healthier, more active lifestyle for the occupants. Reducing single-occupancy vehicle use is a massive priority in the LEED framework, and the most effective way to do this is by providing access to quality transit. Projects earn points by locating the building within a short, safe walking distance to bus stops, light rail stations, or commuter trains. This strategy not only lowers carbon emissions but also provides equitable transportation options for occupants who cannot afford or choose not to own a private car. It is important to remember that simply having a bus stop nearby is not enough, as the transit service must have frequent, reliable daily trips to actually be useful to the building occupants. Beyond public transit, projects are highly encouraged to build infrastructure that supports bicycle networks. However, just putting a simple bike rack in front of the building will not earn you a LEED point. To genuinely encourage cycling, a commercial project must provide secure bicycle storage and clean shower facilities for the people working inside the building. Furthermore, the building must be connected to a safe, continuous bicycle network that reaches into the surrounding community. The exam will test your understanding that real alternative transportation requires comprehensive, supportive infrastructure, not just minor token gestures. For those who must drive, LEED rewards projects that encourage the use of green vehicles and alternative fuels. This is typically achieved by installing electric vehicle charging stations or providing designated, preferred parking spaces for highly efficient cars. Preferred parking spaces are usually located closest to the main entrance, right after the mandatory handicap spots, offering a convenient daily perk for people who drive environmentally friendly vehicles. By making it easier and more rewarding to drive a green vehicle, buildings can help accelerate the global transition away from dirty fossil fuels. Once the location is selected, the focus shifts to the sustainable sites category, beginning with how the actual construction process is managed. The most important prerequisite in this category is construction activity pollution prevention, which every single project must achieve. During construction, heavy machinery tears up the earth, creating loose soil that can easily wash into local sewers and streams during a rainstorm. To prevent this, contractors must implement an erosion and sedimentation control plan. This plan uses physical barriers like silt fences and temporary seeding to keep dirt on the construction site and completely out of the local water supply. Before finalizing the site design, LEED requires a thorough site assessment to understand the unique natural characteristics of the land. This involves studying the local topography, hydrology, climate, vegetation, and human use patterns of the area before drawing any blueprints. By understanding where the sun rises, how the wind blows, and where water naturally pools, designers can place the building in a way that works with nature rather than fighting against it. The exam highlights the site assessment as a critical early step in the integrative process that prevents costly design mistakes later on. To maintain local biodiversity, LEED encourages projects to protect existing natural habitats and restore damaged areas. If a site has existing native trees or untouched meadows, The construction team must clearly fence these areas off to protect them from heavy machinery and foot traffic. If the site is already degraded from previous use, the team can earn points by planting native or adapted vegetation to restore the ecological balance. Native plants are species that naturally grow in that specific region, meaning they require zero chemical fertilizers and very little extra irrigation to survive. Providing quality open space is another major goal within sustainable site development. Open space goes beyond just having a flat grassy lawn, as it must be an accessible, usable outdoor area that connects people to the natural environment. This could be a pedestrian courtyard, a community garden, or a rooftop terrace filled with lush vegetation. Quality open space improves the mental health of building occupants while simultaneously providing small habitats for local birds and beneficial insects. The exam will expect you to differentiate between a paved parking lot and a genuinely beneficial open space. Rainwater management is one of the most critical environmental challenges addressed in this entire section. In a natural forest, rain strikes the ground and slowly soaks into the earth, replenishing underground aquifers safely. However, traditional development covers the land with hard, impervious surfaces like concrete parking lots and asphalt roofs. When rain hits these impervious surfaces, it cannot soak in, creating massive volumes of fast-moving runoff that floods local sewers and carries oil and pollution directly into rivers. Your goal on the exam is to identify strategies that mimic natural hydrology and stop this dangerous runoff. To manage rainwater sustainably, we use a concept called green infrastructure or low-impact development. Instead of piping water away as fast as possible, these strategies focus on capturing and treating rainwater right where it falls on the site. Solutions include building natural rain gardens, installing permeable paving that allows water to seep straight through the concrete, or capturing water in underground cisterns for later use. By slowing the water down and letting the soil naturally filter out pollutants, projects can prevent municipal floods and protect downstream water quality. Another major site issue is the heat island effect, which occurs when urban areas become significantly warmer than their surrounding rural areas. Dark, hard surfaces like black asphalt roads and dark rooftops absorb the heat of the sun during the day and radiate it back into the city all night long. This artificial heat bubble increases the need for air conditioning, drives up energy costs, and can even cause dangerous smog to form in the summer air. The exam will definitely ask you to identify the specific causes and the negative impacts of the urban heat island effect. Defeating the heat island effect requires changing the materials we use on the outside of our buildings. For the roof, projects can install highly reflective materials that bounce the solar radiation back into the atmosphere instead of absorbing it. Alternatively, teams can install a vegetated green roof, which covers the building with living plants that naturally cool the air through a process called evapotranspiration. A green roof is an excellent example of an integrative design strategy because it simultaneously reduces the heat island effect, manages rainwater runoff, and provides quality open space for people. We must also address the heat island effect at the ground level, which LEED refers to as the non-roof areas. Strategies here include shading parking lots with large architectural canopies or planting wide canopy trees to block the sun from ever hitting the hot pavement. Additionally, developers can use light-colored concrete instead of black asphalt for sidewalks and driveways, as the lighter color reflects much more solar heat. Using underground parking is also highly rewarded by LEED, because it completely removes the hot, dark pavement from the surface of the site. The final major site concept is light pollution reduction, which addresses the negative environmental impacts of artificial lighting at night. When exterior lights are too bright or pointed directly up into the sky, they create a glowing haze that blocks our view of the stars and disrupts the natural circadian sleep cycles of humans. Light pollution also severely disorients nocturnal wildlife, particularly migrating birds and newly hatched sea turtles trying to find the ocean. For the exam, you need to know that excessive outdoor lighting is a waste of energy and a direct threat to local ecosystems. To successfully reduce light pollution, lighting engineers must carefully select and position exterior fixtures to only light exactly what is necessary for human safety. We use a metric called the bug rating, which stands for backlight, uplight, and glare, to evaluate exactly how much light is escaping where it should not be. By choosing fixtures with low bug ratings and aiming the light directly down at the ground, projects can keep the night sky dark and beautiful. Motion sensors and automated timers are also excellent tools to ensure exterior lights are only turned on when a person is actually present. Congratulations on completing the second section of this exam preparation course. I strongly encourage you to take the attached practice test for this module while the concepts of location and site development are still incredibly fresh in your mind. Working through practice questions builds your test-taking confidence and is a proven method for improving your final exam score. This specific practice test is included right here with your lesson, so please take advantage of it to reinforce your active learning. Once you are comfortable with this material, I will see you in the next section where we dive into water efficiency and energy systems. Welcome to the third section of your exam preparation, where we dive into the vital topics of water efficiency and energy systems. In this lesson, you will learn how green buildings drastically reduce their consumption of our most precious natural resources. Understanding these systems is incredibly important because commercial buildings use massive amounts of electricity and fresh drinking water every single day. We are going to explore exactly how LEED transforms these resource-hungry structures into highly efficient, sustainable machines. Get ready, because mastering these concepts is going to earn you a significant number of points on your final exam. When approaching resource conservation, the LEED system always promotes an efficiency-first mindset. This simply means that before you look for alternative sources of water or energy, you must first reduce your overall demand as much as possible. It is always cheaper and more effective to need less water in the first place, rather than building an expensive system to capture rainwater. The certification exam will frequently test your understanding of this hierarchy, asking you to prioritize demand reduction over technological solutions. We apply this exact same efficiency-first philosophy to both outdoor landscaping and indoor plumbing fixtures. The first major prerequisite in this category focuses entirely on outdoor water use reduction. Every single LEED project must reduce its outdoor landscape water requirement by at least 30% compared to a traditional baseline building. The baseline is a standardized calculation that tells you how much water a normal, non-green building of the same size would use to keep its grass green. Your job as a green building professional is to prove that your new design uses significantly less water than that standard baseline. If you cannot prove this 30% reduction, the building simply cannot be certified. To achieve this massive reduction in outdoor water use, landscape architects rely on a strategy called xeriscaping. Xeriscaping is a landscaping philosophy that uses drought-tolerant plants, smart soil design, and efficient layouts to almost completely eliminate the need for extra watering. Instead of planting thirsty green grass, a team might plant beautiful native shrubs that naturally survive on the local rainfall alone. If irrigation is absolutely necessary, the team will use highly efficient drip irrigation systems that deliver water directly to the plant roots, rather than spraying it wastefully into the air. Once a project has reduced its outdoor water demand as much as possible, it can then look for alternative water sources to earn additional optional points. Instead of using highly treated municipal drinking water to keep the bushes green, a building can use rainwater captured from the roof. Another excellent alternative is grey water, which is gently used water from bathroom sinks and showers that has not come into contact with human waste. Using captured rainwater or recycled grey water to irrigate the landscaping is a perfect example of the closed-loop systems we discussed in the first section. Moving inside the building, we encounter the prerequisite for indoor water use reduction, which requires a minimum 20% savings compared to the baseline. This calculation looks at the daily water consumed by toilets, urinals, bathroom faucets, kitchen sinks, and showerheads. Earning this prerequisite is entirely about selecting the right hardware during the design phase. The exam will expect you to know that the baseline for a standard toilet is 1.6 gallons per flush, and your new green building must significantly beat that number. The easiest way to reduce indoor water use is by installing high-efficiency fixtures and aerators. An aerator is a small, inexpensive screen attached to a faucet that mixes air into the water stream, making the pressure feel strong while actually using far less water. Project teams are also strongly encouraged to specify products that carry the WaterSense label. WaterSense is a program sponsored by the United States Environmental Protection Agency that certifies plumbing fixtures as being at least 20% more efficient than average products. Seeing the WaterSense label on an exam question is a massive clue that you are looking at a sustainable indoor water strategy. The final prerequisite in the water category is building level water metering. To manage your water use, you must first be able to measure it accurately. LEED requires projects to install permanent water meters that measure the total potable water use for the entire building and its surrounding grounds. Furthermore, the building owner must commit to sharing this water usage data with the Green Building Council for at least 5 years after the building is occupied. This real-world data ensures that the building actually performs the way it was designed to perform. Advanced projects will also look closely at cooling towers, which are massive pieces of equipment used to air-condition large commercial buildings. Cooling towers use the evaporation of water to reject heat from the building into the atmosphere, and they can consume millions of gallons of fresh water every year. To earn points here, engineers must carefully manage the chemistry of the water to maximize how many times it can cycle through the system before being dumped down the drain. You do not need to be a chemical engineer for the exam, but you do need to know that cooling towers are a primary target for advanced water conservation. Next, we transition into the energy and atmosphere category, which is arguably the most critical section of the entire LEED rating system. This category contains the highest number of available points because energy consumption is directly tied to greenhouse gas emissions and global climate change. The primary goal here is to drastically reduce the amount of energy the building needs, and then supply that remaining energy with clean, renewable sources. The exam places a massive emphasis on energy, so you must pay close attention to the specific strategies we are about to cover. The cornerstone of the energy category is the minimum energy performance prerequisite. Just like the water category, you must prove that your proposed building is significantly more efficient than a standard baseline building. Teams usually prove this by creating a whole building energy simulation, which is a complex computer model that predicts how the building will behave under various weather conditions and occupancy schedules. The computer model compares the green design against a standard building code design to calculate the exact percentage of energy saved. To ensure that all these complex energy systems actually work, LEED requires a process called fundamental commissioning. Commissioning is a quality assurance process where an independent, third-party expert verifies that the heating, cooling, plumbing, and electrical systems are installed and operating exactly as the designers intended. Think of the commissioning authority as an independent building inspector who works for the owner, making sure they actually get the high-performance building they paid for. The exam will test your knowledge that fundamental commissioning is a mandatory prerequisite, while enhanced commissioning earns optional points. Another crucial prerequisite involves the management of refrigerants, which are the chemical fluids used inside air conditioners and refrigerators. For decades, the construction industry used chlorofluorocarbons, commonly known as CFCs, which are incredibly destructive to the protective ozone layer of the Earth. LEED strictly mandates zero use of CFC-based refrigerants in new buildings, aligning with the international treaty known as the Montreal Protocol. On the exam, if you see a question about ozone depletion, the answer will almost always relate to the phase-out of CFC refrigerants. Once the prerequisites are met, projects can pursue the Optimize Energy Performance credit, which offers more points than any other single credit in LEED. To earn maximum points here, the team must employ an integrative design to dramatically lower energy use. This includes adding thicker insulation, installing high-performance windows, using ultra-efficient LED lighting, and designing the building to maximize natural daylight. Every single percentage point of energy saved beyond the prerequisite baseline translates directly into more LEED points for the project. While the prerequisite requires a single energy meter for the whole building, the advanced energy metering credit rewards projects for installing multiple submeters. Submeters track energy use on individual floors, in specific departments, or on large, energy-intensive equipment like the main chilling units. By monitoring energy use at this granular level, facility managers can quickly identify exactly where electricity is being wasted. If a submeter shows that the lights on the third floor are running all night long, the manager can instantly fix the problem and save money. After reducing the energy demand as much as physically possible, the project can earn points by producing renewable energy right on the construction site. The most common examples of on-site renewable energy are solar panels placed on the roof or small wind turbines located on the property. Producing power on-site reduces the building's reliance on the dirty fossil fuel grid and prevents energy from being lost during transmission over long-distance power lines. The exam will ask you to calculate the percentage of the total energy cost that is offset by these on-site renewable systems. Another highly innovative strategy is called demand response. During hot summer days, everyone turns on their air conditioning at the same time, putting massive stress on the local power grid and risking blackouts. A demand response program is an agreement where the building owner promises to automatically reduce their electricity use when the power company sends a signal that the grid is stressed. The building might temporarily dim the lights or turn the air conditioning down slightly, helping to stabilize the city grid while earning the building owner financial rebates and LEED points. If a project simply cannot generate enough renewable energy on its own property, it can still earn points by purchasing green power and carbon offsets from off-site sources. A building owner can sign a contract to buy renewable energy certificates, which guarantee that clean power from a distant wind farm or solar facility is being added to the national grid on their behalf. Carbon offsets go a step further by funding projects that actively remove greenhouse gases from the atmosphere, such as planting vast new forests. This allows urban buildings with limited roof space to still achieve their climate goals. Before we conclude, we must apply our systems thinking skills to see how water and energy are permanently linked. It takes a massive amount of electrical energy to pump fresh water from a reservoir, treat it at a chemical plant, and push it up to the 10th floor of an office building. Furthermore, it takes even more energy to heat that water for sinks and showers. Therefore, every single drop of water you save through efficient fixtures also saves the electricity that would have been used to pump and heat it. The exam loves questions that highlight this interconnected energy-water nexus. Congratulations on completing the third section of your certification training. You are now heavily equipped to tackle questions regarding water conservation and energy optimization. I strongly encourage you to pause right now and complete the attached practice test for this specific section. Engaging with these practice questions is the absolute best way to improve your retention and guarantee your exam readiness. This targeted practice test is included with your lesson to ensure your active learning continues. Keep up the excellent momentum, and I look forward to seeing you in the next section where we will conquer materials, resources, and waste management. Welcome to the fourth section of your exam preparation course, which focuses on materials, resources, and waste management. In this lesson, you will learn how the physical products we use to construct and operate buildings impact our planet from the moment they are manufactured to the day they are thrown away. Understanding material life cycles is incredibly important because the construction industry consumes a massive portion of global raw materials and generates millions of tons of landfill waste every year. Get ready to rethink everything you know about buying and disposing of building supplies. Let us explore how smart material choices can drastically shrink the environmental footprint of your project. The core philosophy of the materials and resources category is to shift the construction industry away from a traditional linear economy and toward a circular economy. In a linear economy, we take raw materials from the earth, make products, use them once, and dispose of them in a landfill. A circular economy, however, is designed to keep materials in continuous use, mimicking natural systems where there is no such thing as waste. The exam will test your understanding of how LEED rewards projects for reducing demand, reusing existing resources, and specifying products that can be safely recycled back into the manufacturing loop. To establish a baseline of good behavior, every single LEED project must achieve the prerequisite for the storage and collection of recyclables. This means the building designers must provide dedicated, easily accessible floor space for the collection of everyday recyclable materials. At a minimum, the building must collect mixed paper, corrugated cardboard, glass, plastics, and metals. The exam will expect you to know this exact list of 5 mandatory materials, because failing to provide space for even one of them will disqualify the entire project from certification. In addition to those 5 everyday materials, the prerequisite requires the project to safely store and dispose of at least 2 of the following 3 hazardous items, which are batteries, electronic waste, and mercury-containing lamps. These items contain toxic chemicals that can severely pollute groundwater if they are thrown into a standard garbage dumpster. You must be able to clearly distinguish between the 5 mandatory everyday recyclables and these specialized waste streams on your exam. Providing a safe, designated drop-off bin for old computer monitors and burnt-out light bulbs is a simple but mandatory step in sustainable building operations. The second major prerequisite in this category is the Construction and Demolition Waste Management Plan. Before a single shovel hits the dirt, the contractor must write a comprehensive plan detailing exactly how they will prevent construction waste from ending up in a local landfill. The plan must identify at least 5 different materials that will be diverted from the trash, such as concrete rubble, scrap wood, drywall, and metal framing. The contractor must also specify whether these materials will be separated directly on the construction site or sent to a massive sorting facility off-site. When discussing waste, it is vital to understand the difference between waste diversion and source reduction, because LEED strongly prefers source reduction. Waste diversion means taking trash that has already been created and sending it to a recycling plant instead of a landfill. Source reduction, on the other hand, means preventing the waste from ever being created in the first place. Strategies for source reduction include using prefabricated modular components built perfectly to size in a factory, which completely eliminates the piles of scrap material usually left behind on a messy construction site. One of the most powerful ways to practice source reduction is to completely avoid building a new structure and instead reuse an existing building. The Building Life Cycle Impact Reduction credit heavily rewards projects that renovate historic structures, revitalize abandoned blighted buildings, or salvage major structural elements from an old site. Reusing an existing brick wall is always more sustainable than manufacturing, shipping, and laying brand new bricks. The exam will frequently highlight building reuse as the ultimate form of material conservation. The primary reason reusing an existing building is so sustainable is because it preserves the embodied energy of the structure. Embodied energy represents the total amount of energy that was consumed to extract, manufacture, transport, and install a building material when it was first created. If you demolish an old concrete building, all of that original embodied energy is completely wasted, and you have to spend massive amounts of new energy to build a replacement. A common exam question will ask you to identify embodied energy as the hidden environmental cost trapped inside every physical material. For projects that must build brand new structures, LEED offers points for conducting a whole building life cycle assessment. We discussed life cycle assessments in Section 1, but here the team must use a computer model to prove that their new design reduces negative environmental impacts by at least 10% compared to a standard baseline building. The team must look at specific impact categories, such as global warming potential, ozone depletion, and the acidification of land and water. This scientific approach ensures the design team is making choices that genuinely protect the planet, rather than just guessing which materials seem green. A major focus of the modern LEED rating system is transparency, which is heavily tested through a series of credits known as Building Product Disclosure and Optimization. The first optimization credit focuses on environmental product declarations, commonly referred to as EPDs. You can think of an EPD as a comprehensive nutrition label for a building material, but instead of showing calories and fat, it shows the exact environmental impacts of creating that product. By requiring EPDs, LEED forces manufacturers to be completely honest about how their products affect the earth, allowing architects to compare different brands and choose the least damaging option. For the exam, you need to understand that not all EPDs are created equal. An industry-wide EPD represents an average environmental impact for a general type of product, like standard drywall made by multiple different companies. A product-specific Type 3 EPD, however, is a rigorously verified document for one exact product made by one specific manufacturer. Because product-specific EPDs provide much better transparency, LEED calculations value them higher than generic industry-wide documents. Choosing materials with specific, third-party verified EPDs is a fast track to earning points in this category. The next disclosure and optimization credit focuses on the sourcing of raw materials. This credit evaluates where a manufacturer gets their ingredients and how they treat the environment and their workers during extraction. Projects earn points by selecting materials from companies that publish corporate sustainability reports, which publicly document their environmental and social impacts. Earning this credit proves that your building materials were not sourced through destructive mining practices or exploitative labor, extending your sustainable impact far beyond the physical boundaries of the construction site. Within the raw materials credit, projects can also earn optimization points by using bio-based materials, certified wood products, and materials with recycled content. If a project uses new wood, it must be certified by the Forest Stewardship Council, or FSC, which guarantees the timber was harvested from a responsibly managed forest that protects wildlife and worker rights. If a project uses recycled materials, the exam will expect you to clearly differentiate between the two distinct types of recycled content, which are pre-consumer and post-consumer. Mixing these two definitions up is a very common mistake for test takers. Post-consumer recycled content comes from materials that have been used by a normal person, thrown in the recycling bin, and turned into something new, like an aluminum can melted down to make window frames. Pre-consumer recycled content, on the other hand, comes from scrap materials generated during the manufacturing process, such as sawdust swept off a factory floor and pressed into particle board. LEED places a much higher value on post-consumer content because it actively removes consumer trash from the municipal waste stream. Whenever you have the choice, post-consumer recycled materials will always earn you more credit weight. LEED also wants to reduce the pollution caused by heavy diesel trucks driving building materials across the country. To encourage local purchasing, LEED includes a regional multiplier for materials that are extracted, manufactured, and purchased within 100 miles of the project site. If a material meets all the requirements of a specific credit and is also sourced within this 100-mile radius, it is valued at 200% of its actual cost in the credit calculations. Knowing this 100-mile radius and how it acts as a regional multiplier is an absolute must for passing the certification exam. The final major disclosure credit focuses on material ingredients, which is primarily concerned with human health and toxic chemicals. Instead of looking at carbon emissions, this credit uses tools like health product declarations, or HPDs, to reveal exactly what chemical compounds are hidden inside building materials. Many common building products contain hazardous chemicals that can cause asthma or cancer, but manufacturers traditionally keep these formulas secret. By demanding HPDs, LEED projects force manufacturers to disclose these hidden toxins, allowing designers to protect the people who will eventually live and work in the building. To maximize points for material ingredients, project teams often look for products that have achieved cradle-to-cradle certification. Cradle-to-Cradle is an advanced, independent certification program that evaluates a product based on material health, material reutilization, renewable energy use, water stewardship, and social fairness. If an architect specifies a cradle-to-cradle certified carpet, they can be completely confident that the carpet contains no toxic chemicals and is designed to be easily recycled into new carpet at the end of its useful life. The exam frequently uses cradle-to-cradle as the ultimate example of healthy, circular product design. While you are studying for the exam, you should be aware that certain building types have unique material requirements. For example, a hospital seeking LEED for healthcare has specialized credits focused on reducing toxic chemicals found in medical equipment and heavy metals like lead and cadmium. Similarly, retail projects have specific guidelines regarding the materials used for their massive product displays and cash register checkout stands. While you do not need to memorize every detail of these specialized rating systems, knowing that different building types face unique material challenges is important for your overall understanding of the LEED framework. Finally, material management does not stop when the construction is finished, as building operators must continuously purchase supplies for daily ongoing operations. Green buildings implement sustainable purchasing policies that govern everything from buying highly efficient computers and low-mercury light bulbs, to requiring 100% recycled printer paper. Even the cleaning chemicals and janitorial supplies must meet strict environmental standards to protect the cleaning staff from breathing toxic fumes. This proves that earning a LEED certification is not just about how you build the building, but how you responsibly manage it for decades to come. Congratulations on successfully completing the 4th section of your exam preparation course. I highly encourage you to immediately take the attached practice test for this module while these material and resource concepts are fresh in your mind. Answering practice questions is scientifically proven to improve long-term retention and ensures you are genuinely ready for the real exam environment. Please remember that this practice test is included right here with your lesson to support your active learning journey. Keep up this fantastic effort, and I will see you in the next section where we will explore the critical importance of indoor environmental quality. Welcome to the 5th section of our exam preparation course, focusing on indoor environmental quality. In this lesson, you will learn how green buildings protect the health, comfort, and daily productivity of their human occupants. Understanding this category is vital because modern people spend roughly 90% of their time indoors, making the quality of the indoor air and environment a major factor in human well-being. We are going to explore exactly how LEED strategies transform stuffy, unhealthy buildings into vibrant spaces that help people thrive. Get ready, because mastering these comfort strategies is a guaranteed way to pick up valuable points on your exam. The first major prerequisite in this category is minimum indoor air quality performance. Every single LEED project must provide adequate ventilation by bringing enough fresh outdoor air into the building to dilute indoor pollutants. If a building is sealed up too tightly to save energy, it traps stale air, carbon dioxide, and airborne chemicals inside, which can make occupants feel drowsy, sick, and unproductive. The exam will heavily test your understanding of ASHRAE Standard 62.1, which is the official industry guideline used by LEED to determine the mandatory minimum ventilation rates for commercial buildings. Another critical indoor prerequisite is environmental tobacco smoke control. Second-hand smoke contains thousands of dangerous chemicals and is a well-known carcinogen that severely threatens human health. To satisfy this prerequisite, a project must completely prohibit smoking inside the building and in all outdoor areas close to air intakes and entryways. For multi-family residential buildings, smoking might be allowed inside private apartments, but only if the units are completely sealed off from common hallways and neighboring units using airtight construction. Expect the exam to present scenarios regarding smoking restrictions in public versus residential spaces. Once the vital prerequisites are met, projects can pursue optional points by significantly improving their indoor air quality through enhanced ventilation strategies. Teams can install automated carbon dioxide sensors that monitor air freshness in crowded rooms like conference halls and classrooms. When the carbon dioxide levels rise too high, indicating that the air is getting stale, the system automatically opens dampers to let more fresh outdoor air rush inside. This responsive approach ensures that occupants always have access to clean, oxygen-rich air while avoiding the energy waste of running ventilation fans at full speed all day long. Another major focus of indoor environmental quality is managing construction pollution to protect the air system before people even move into the building. During construction, cutting drywall, painting walls, and installing new carpet releases heavy dust and toxic fumes that can coat the inside of the heating and cooling ducts. If those ducts are not protected, the ventilation system will blow that toxic construction dust straight into the lungs of the first occupants. To prevent this, LEED requires contractors to keep all ductwork tightly sealed until the building is completely finished and ready for occupancy. If construction dust does manage to get into the building, the team must implement a comprehensive indoor air quality management plan during construction. This plan includes strategies like using powerful portable air scrubbers with high-efficiency particulate air filters to continuously clean the indoor air. Furthermore, the contractor must run the permanent heating and cooling system with brand new, high-grade filters for a designated period before anyone is allowed to occupy the building. This process, known as a building flush-out, blows massive volumes of fresh air through the structure to safely expel all lingering construction odors and chemical residues. After the building is constructed, the next major challenge is managing the chemical emissions of the products brought inside on a daily basis. Many common building materials, such as paints, adhesives, sealants, and carpets, release volatile organic compounds, commonly known as VOCs. Volatile organic compounds are liquid or solid chemicals that easily vaporize into the air at room temperature, creating that strong new car smell or paint odor. Breathing these toxic chemical fumes can cause severe headaches, dizziness, and long-term respiratory damage. The exam will frequently test your ability to identify VOCs as a primary target for indoor pollution control. To minimize these dangerous fumes, LEED requires low-emitting materials across multiple categories, including paints, coatings, flooring, and composite wood products. Instead of just guessing, architects must look for products that have been tested and certified by independent organizations to prove they emit very low levels of volatile organic compounds. For instance, composite wood products like plywood and particle board must use specialized binding resins that do not contain formaldehyde, which is a notorious carcinogen. Specifying low-emitting materials is one of the most effective ways to ensure the building is truly safe for human occupancy. Another critical aspect of indoor environmental quality is thermal comfort, which ensures that occupants are not too hot or too cold while working. Thermal comfort is influenced by a combination of factors, including air temperature, radiant heat from the sun, relative humidity, and indoor airspeed. The exam will expect you to know ASHRAE Standard 55, which is the official benchmark LEED uses to define the acceptable thermal comfort ranges for building occupants. Designing a system that meets this standard prevents the common office disputes where one person is freezing in a heavy sweater while another is sweating. To achieve optimal thermal comfort, LEED rewards projects that give individual occupants control over their immediate work environment. This can be accomplished by installing local desk thermostats, adjustable window blinds, or personal task lighting that allows employees to customize their personal workspace. When people have the power to adjust their immediate surroundings, they report significantly higher levels of job satisfaction and daily productivity. The exam loves to highlight occupant control as a hallmark of advanced, human-centered green building design. Lighting quality is another major component of indoor environmental quality that profoundly impacts human health, mood, and sleep cycles. Natural daylight is universally recognized as the best possible light source for human eyes, but traditional buildings often rely entirely on harsh artificial fluorescent lighting. To earn daylight credits, architects must design buildings with large windows, interior glass walls, and open layouts that allow deep penetration of sunlight into the core of the workspace. A building with abundant natural daylight requires less electricity for lighting and keeps occupants feeling energized throughout the day. While natural daylight is fantastic, too much direct sunlight can cause severe glare on computer screens and overheating near windows. To solve this, LEED projects must install effective lighting controls, such as automatic motorized roller shades or adjustable architectural louvers that block harsh glare while still letting soft daylight in. Furthermore, artificial lighting systems must be equipped with sensors that automatically dim the electric lights when bright sunlight is already flooding the room. Balancing natural daylight with advanced glare control is a classic challenge tested on the certification exam. Access to quality views to the outside world is heavily rewarded by the LEED rating system. Studies consistently show that being able to look out a window at trees, sky, or human activity dramatically reduces stress, lowers blood pressure, and accelerates healing in hospital patients. To earn the quality views credit, a specific percentage of all regularly occupied floor area must have a direct line of sight to the outdoor environment through clear vision glazing. The exam will expect you to know that blocking windows with solid interior walls or deep, dark cubicles prevents a project from achieving this important human health credit. Acoustic performance is often overlooked by amateur designers, but it is a mandatory or heavily incentivized credit in many modern LEED rating systems. Unwanted noise from traffic outside, loud mechanical equipment in the basement, or echo in a hallway can severely disrupt concentration and increase chronic stress. To achieve good acoustic performance, engineers must carefully design walls and ceilings with proper sound insulation, install acoustic ceiling tiles, and select quiet heating and cooling equipment. The exam will test your understanding that a truly green building must protect its occupants from both chemical pollution and disruptive noise pollution. In addition to daily comfort, modern green building design places a heavy emphasis on biophilic design elements. Biophilia is the innate human tendency to seek connections with nature and other forms of life. Projects can incorporate biophilic design by using natural wood finishes, installing living green walls covered in tropical plants, or featuring indoor water fountains. These natural elements lower human stress levels and create a calming, restorative atmosphere inside dense urban office buildings. Recognizing biophilia as a powerful tool for mental health is becoming increasingly common on the professional exam. Once the building is fully occupied, maintaining high indoor environmental quality requires ongoing monitoring and active management. Facility operators must ensure that ventilation systems continue to bring in fresh air and that air filters are replaced on a strict, regular schedule. If filters are left to clog with dust and pollen, the airflow drops drastically, forcing the mechanical fans to work harder and wasting large amounts of electricity. The exam reinforces the concept that sustainability does not end on the day construction finishes, but requires vigilant operational care to protect human health over the long term. Facility managers also rely on occupant feedback mechanisms, such as annual indoor environmental quality surveys, to catch problems early. If a large number of employees in the south wing complain of headaches or stuffy air, the manager knows immediately to check the local ventilation dampers in that specific zone. This proactive approach prevents small mechanical issues from turning into major health hazards for the people working inside the building. Listening to the human occupants is the ultimate test of whether your indoor environmental strategies are actually working in the real world. When studying for the exam, you should note that certain specialized building types have unique indoor quality requirements. For example, a LEED for healthcare project must maintain extremely strict air pressure relationships between different hospital rooms to ensure that contagious airborne diseases cannot spread from an isolation ward into the public hallways. Similarly, a school rating system has rigorous standards for classroom acoustics and glare control to ensure children can hear their teachers clearly and learn effectively. Knowing that these specialized rules exist will help you navigate tricky scenario questions on test day. Everything we have discussed in this section ties back to the core realization that buildings are built for people, not just for saving energy. A building that uses zero energy is a failure if the air inside is so toxic that it makes the human occupants sick. The triple bottom line we learned about in the first section always places human health right alongside environmental protection and financial profit. The certification exam will consistently challenge you to balance energy efficiency with superior indoor environmental quality, ensuring that green buildings are truly healthy places to live and work. Congratulations on successfully completing the 5th section of your exam preparation course. I strongly encourage you to immediately take the attached practice test for this module while these indoor environmental quality concepts are fresh in your mind. Answering practice questions right now is the absolute best way to lock in your knowledge and guarantee your exam readiness. Please remember that this practice test is included right here with your lesson to support your active learning journey. Keep up this incredible momentum, and I will see you in the final section where we will master innovation, regional priorities, and advanced exam strategies. Welcome to the final section of your LEED app exam preparation course. In this concluding lesson, we will explore how projects earn bonus points through exceptional design innovation and region-specific environmental concerns. We will also cover how to successfully navigate the documentation process within LEED Online and review proven strategies for passing your certification exam on the first try. You have worked hard to build a comprehensive understanding of green building principles, and this final module will tie everything together. Let us dive in and get you fully prepared to earn your professional credential. The first major topic in this final section is the innovation category, which rewards project teams for pushing the boundaries of sustainable design. Sometimes a brilliant design team invents a groundbreaking strategy that significantly improves the building, but that exact strategy is not explicitly mentioned anywhere in the standard LEED reference guide. To ensure these visionary ideas are not penalized, LEED provides an innovation path where teams can propose novel solutions. To earn an innovation point, the team must prove that their strategy provides comprehensive, quantifiable environmental benefits that go far beyond what is normally required by the rating system. There are several standard ways a project team can successfully earn innovation points without inventing a brand new technology from scratch. One common path is to achieve exceptional performance on an existing credit, such as doubling the required percentage of recycled materials or reducing energy use far beyond the maximum threshold of the standard optimization table. Another path is to pilot an experimental credit from the official LEED Pilot Credit Library, which is a collection of cutting-edge strategies currently being tested for future versions of the rating system. The exam will frequently test your ability to recognize these standard pathways for earning bonus innovation points. Every project pursuing innovation must also include at least one LEED-accredited professional as a core member of the project team. Having a dedicated LEED app on board ensures that someone with deep, verified expertise in green building systems is actively guiding the design and documentation process. This is essentially an automatic bonus point for simply having the professional credential you are currently studying to earn. The exam loves to remind candidates that professional expertise is viewed as a vital asset to the overall quality and success of a sustainable project. Closely related to innovation is the regional priority category, which acknowledges that environmental challenges vary drastically depending on where the building is constructed. A water conservation strategy that is absolutely critical for a desert project in Arizona might be completely irrelevant for a project built in a rainy rainforest in Washington state. To address this, the United States Green Building Council developed a list of regionally specific credits tailored to every single zip code and country across the globe. The exam will expect you to know that regional priority credits are existing credits from the standard rating system that have been highlighted as exceptionally important for that specific geographic area. A project can earn up to 4 bonus regional priority points by focusing heavily on the specific environmental issues that plague their local community. For example, if a certain county suffers from severe smog and air pollution, regional priority points might be assigned to alternative transportation and advanced air filtration credits. These regional points encourage developers to solve local ecological crises while simultaneously boosting their overall LEED scorecard. You do not need to memorize the regional priorities for every city in the world for the exam, but you must understand how the system automatically assigns them based on the official project address entered into LEED Online. Once all the credits, innovations, and regional priorities are calculated, the project team must compile their final evidence and submit the package for official review. This brings us back to LEED Online, the digital platform we discussed in Section 1, where the project administrator oversees the final submission workflow. Every single credit claimed by the team must be backed up by rigorous documentation, such as architectural drawings, manufacturer cut sheets, energy simulation reports, and signed contractor affidavits. Reviewers at the Green Business Certification Incorporated examine these documents line by line to verify that the project truly complies with all requirements. A major part of the final documentation process involves rigorous quality control to avoid costly review delays or point rejections. The project administrator must carefully review all uploaded templates to ensure there are no math errors, conflicting statements, or missing file attachments. If a reviewer finds incomplete documentation, they will issue a comment requesting clarification, which temporarily halts the final certification timeline. The exam often highlights the importance of thorough internal quality checks before hitting the final submit button to ensure a smooth, rapid review process. Now that you understand how a project moves from design to final certification, let us shift our focus directly to the logistics of taking and passing your actual certification exam. The LEED app exam is typically taken at a secure, proctored testing center, or remotely through an online proctoring service using your home computer. You will have a strict time limit of 2 hours to complete the entire examination, which consists of 100 multiple-choice questions. Managing your time effectively during the test is critical, meaning you should never get bogged down on a single difficult question for too long. The exam is split into 2 distinct parts, although you can move freely between them during your allotted time window. The first part is the LEED Core Concepts exam, which tests your general knowledge of green building principles, environmental issues, and the triple bottom line. The second part is the LEED App Specialty exam, which dives deep into the technical credits, calculations, and strategies specific to your chosen rating system, such as building design and construction. To pass, you must achieve a scaled score of at least 170 out of 200 possible points. When you sit down at the testing computer, you will encounter several different styles of multiple-choice questions designed to test your real-world comprehension. Some questions are straightforward knowledge recalls, asking you to identify the definition of a brownfield or the minimum percentage required for a water efficiency prerequisite. Other questions are complex, scenario-based puzzles that describe a specific building project and ask you to identify the best integrative strategy or the correct credit calculation. Preparing for these scenarios requires you to understand why we use these green building strategies, rather than just memorizing vocabulary lists. A common trap for test takers is overthinking scenario questions by imagining overly complex or unlikely exceptions to the rules. Always read the question carefully and look for standard LEED terminology, such as baseline, threshold, prerequisite, or integrative process. If a question asks how to handle a construction site with heavy sediment runoff, your mind should instantly jump to the erosion and sedimentation control plan we covered in Section 2. Trust your preparation, rely on the core concepts you have learned throughout this course, and pick the most direct, standard green building answer. Pay extremely close attention to qualifying words within the exam questions, such as always, never, except, most, and least. For instance, if a question asks which of the following is not an acceptable strategy for reducing the urban heat island effect, you must look for the one distractor that actually contributes to heat absorption, like a dark asphalt parking lot. The test writers use these negative framing words specifically to catch students who are reading too quickly, so slowing down and underlining key words on your scratch paper is a proven test-taking hack. If you encounter a particularly difficult question that you are unsure about, do not panic and waste precious minutes staring at the screen. The testing software allows you to flag any question and skip it, returning to it later after you have answered the easier ones. Answering the questions you know first builds your confidence, locks in guaranteed points, and clears your mind so you can tackle the tougher conceptual problems at the end of your time window. Never leave a multiple-choice question blank, because unanswered questions are automatically marked incorrect, whereas a wild guess still gives you a 25% chance of being right. Beyond exam day tactics, your long-term success as a LEED-accredited professional depends heavily on your ability to communicate these concepts to real-world clients. Building owners do not always care about environmentalism for its own sake, but they care deeply about lowering operating costs, increasing property value, and attracting high-end tenants. When you work in the field, you must translate complex technical credits like life cycle assessments and energy modeling into simple business arguments about return on investment. Your professional credential gives you the authority to guide these financial and environmental decisions with confidence. Once you pass your exam and earn your official credential, your educational journey does not stop there, because LEED credentials require ongoing maintenance. To keep your LEED app status active, you must earn a specific number of continuing education hours every 2 years through professional seminars, advanced courses, or industry conferences. This continuing education requirement ensures that you stay up to date with the latest versions of the rating system, new green technologies, and evolving global sustainability standards. Being a true professional means committing to lifelong learning within your field. Let us take a moment to reflect on everything you have accomplished throughout this comprehensive exam preparation course. You started by exploring the foundational history of sustainable design, the integrative process, and minimum program requirements. You then journeyed through site selection, alternative transportation, water conservation, and advanced energy optimization systems. You mastered the complex world of material life cycles, waste diversion, indoor environmental quality, and human health comfort standards. Finally, you have learned how innovation and regional priorities tie the entire green building framework together into a cohesive, powerful tool for planetary protection. You now possess the exact knowledge, technical vocabulary, and strategic mindset required to walk into the testing center and conquer the LEED app examination. The world of construction and real estate is undergoing a massive, permanent transformation towards sustainability, and skilled professionals who understand these systems are in exceptionally high demand. Developers, architects, and municipal governments desperately need trained leaders who can bridge the gap between financial profit and environmental responsibility. By earning your credential, you are stepping directly into that vital leadership role to help shape the sustainable cities of our future. Before you schedule your official exam, make sure you take full advantage of all the practice tests and review materials provided throughout this course. Go back over any tricky modules where you felt less confident, reread the core definitions, and ensure you can easily distinguish between prerequisites and optional credits. Active learning, consistent practice, and calm focus are the ultimate keys to your success on test day. Trust in the rigorous preparation you have put in, stay positive, and remember that you have everything it takes to achieve your professional goals. Congratulations on successfully completing the final section and finishing your entire LEED app exam preparation course. I strongly encourage you to immediately take the comprehensive final practice test included right here with your lesson to test your cumulative knowledge. Engaging with these final practice questions will solidify your mastery and give you the absolute confidence you need to pass the real exam. Thank you for your dedication throughout this learning journey, and I wish you the very greatest success as you take your exam and begin your professional career as a certified LEED app.